A circle is a set of points in a plane, all of which are equidistant from a fixed point. The fixed point is called the center of the circle, and the distance from any point of the circle to the center is called the radius of the circle. Let us have now the standard form of the equation of a circle. So the standard form of an equation of a circle of radius r with center at the origin is x squared plus y squared is equal to r squared. You study the illustrations. This is the center represented by C. We have the segment or the radius represented by R, and the endpoint of the radius on the circle with coordinates represented by X and Y. Let us have an example. We have the center at the origin, then draw a circle, and you have the radius equivalent to 3 units, and this point on the circle with coordinates 2 and 2.24. And do not forget to label the circle properly with its equation, center, the radius, and the corresponding point on the circle. Let us have examples on how to identify the center and the radius given the equation of the circle. For number 1, the given is x squared plus y squared is equal to 9. So the center is at the origin with coordinates 0, 0. And the radius is equivalent to 3 units. All you have to do is to take the square root of 9, because this portion is equivalent to r squared. So r squared, the square root of 9, is 3. Next, given x squared plus y squared is equal to 25. So again, if the form is like this is the standard form where the center is at the origin. So the coordinates of the center, we have 0, 0. And the value of the radius is 5 units because the square root of 25 is 5. Another example, we have x squared plus y squared is equal to 10. So the center, we have the coordinates 0, 0. And then you can express the radius as the square root of 10. You don't have to change it to decimal. You can use the radical form. So r is equal to the square root of 10 units. For number 4, the given is 4x squared plus 4y squared is equal to 48. The center with coordinates 0, 0, still at the origin, and the radius is 2 times square root of 3 units. Let us have the solutions for number 4. Given 4x squared plus 4y squared is equal to 48, you have to simplify the equation by dividing each member of the equation by 4. So what we have, we can cancel 4 here, and 48 over 4 is equal to 12. So we have now x squared plus y squared is equal to 12. So the center is at the origin, so the coordinates, we have 0, 0. And to solve for the radius, this part is the r squared. So r squared is equivalent to 12. All you have to do is to extract the square root of both sides. So we can cancel the square together with the symbol. Then simplify the radicand, then we have r is equal to the square root of 4 times 3. Then we can separate square root of 4 times square root of 3. The square root of 4 is 2, then copy square root of 3. That is why the value of the radius is 2 times the square root of 3. Next, let us have the standard form of an equation of a circle of radius r with center at hk, meaning the center is not at the origin, is equal to the square of x minus h plus the square of y minus k is equal to r squared. This is the illustration. The circle is located at the first quadrant. So this is now the center. We have the radius. And this is the standard form of the equation. So let us have an example. There you have the center, the radius, the point, and then the circle. So the name of the circle is the square of x minus 3 plus the square of y minus 3 is equal to 4. Let us have more examples. Given the equation, we have to identify the center and the radius. For number 1, the center with coordinates 3 and 3. For the radius, the square root of 4 is 2. So r is equal to 2 units. For number 2, the coordinates of the center, we have 2 and 5 because h is 2 and k is 5. And the square root of 16 is 4. So r is equal to 4 units. For number 3, the given is x squared plus the square of y plus 1 is equal to 5 squared. Since this is only x squared, so the value of h is 0. And here, this is positive 1. So originally, this is y minus negative 1. So the value of k is negative 1. That is why the coordinates of the center, we have 0, negative 1. And the value of r is 5 units. For number 4, the square of x plus 2 plus the square of y plus 6 is equal to 49 over 4. And the coordinates, we have negative 2 and negative 6. And for the radius, we have 7 over 2 units. Let us have the solutions for number 4. We have to find the value of h and k. So this is the given equation. So all we have to do is to simplify the equation by expressing it in the standard form of the equation of the circle where the center is hk. So x plus 2 and y plus 6 can be expressed into x minus negative 2, y minus negative 6. Therefore, h is equal to negative 2 and k is equal to negative 6. That is why the center is with coordinates negative 2 and negative 6. And to find for the value of the radius, we have r squared is equal to 49 over 4. So just simply extract the square root of both sides. Then what is left here is r. We cancel the symbol together with the square. And the square root of 49 is 7. The square root of 4 is 2. That is why r is equal to 7 over 2 units. Next, let us have the derivation of standard equation of the circle, which is the square of x minus h plus the square of y minus k is equal to r squared, with radius r and the center hk. Recall the distance formula. So the distance formula is p sub 1, p sub 2 is equal to the square root of the square of x minus 2 minus x sub 1 plus the square of y sub 2 minus y sub 1. Square both sides and simplify. So we have to square this and also the other side. Then here, we can cancel the square together with the symbol. So what is left is only this expression. Since P1 and P2 is equal to R, or the distance of the radius, and the center at point HK, then we have to substitute r squared to this expression, h to x sub 1 and k to y sub 1. So what we have, using this formula, we have to substitute r squared here, x sub 2 minus h here, and y sub 2 minus k here. Then we have to remove the subscripts. We only have x minus h, then y minus k. Then apply the symmetric property of equality. What we have is the square of x minus h plus the square of y minus k is equal to r squared. This is how to get the standard form of the equation of the circle where the center is not at the origin and represented by hk. For the center at the origin, we have to use the standard equation of the circle. And then substitute 0 to h, 0 to k, since the coordinates of the center are 0, 0, and then simplify. So it's like this. H is equivalent to 0 and k is equivalent to 0. X minus 0 is x. Y minus 0 is y. That is why we have x squared plus y squared is equal to r squared of the equation of the circle where the center is at the origin. Let us have now the general form of the equation of a circle. Algebra can be used to rearrange the standard equation of a circle to the general form of a circle. Let's expand it so that you can use more easily and see how it turns into the general form. The general form of the equation of a circle is x squared plus y squared plus dx plus ey plus f is equal to 0. You can recognize it because the two leading terms will always be x squared and y squared. Let us have an example. Express the given standard equation of a circle, the square of x minus 2 plus the square of y minus 3 is equal to 25 into general form. For the solutions, first we have to copy the standard form of the equation. This is the given. And then we have to expand the square of binomial. So the square of x minus 2 is equivalent to x squared minus 4x plus 4. The square of y minus 3 is equivalent to y squared minus 6y plus 9. Then copy 25. And then you can remove the grouping symbols. So just copy without the symbol. Then simplify. Write first x squared followed by y squared, then negative 4x, negative 6y, then 4 followed by 9 is equal to 25. And then you can transpose 25 to this side, equate to 0. Combine 4, 9, and negative 25, so what we have, negative 12. And the general form of the equation of the circle is x squared plus y squared minus 4x minus 6y minus 12 is equal to 0. So this is now the equivalent general form of the given standard form. And this is the illustration of the circle. Identifying the center with coordinates 2 and 3 because h is equivalent to 2 and k is 3. The radius is 5 since the square root of 25 is 5. And this point with coordinates 6, 6. Next example. Express the given general form of the equation of the circle x squared plus y squared minus 4x minus 6y minus 12 is equal to 0 into standard form. Meaning we have to change this general form in standard form. And this is the general form of the previous slide. So we have to go back to the original given standard form. First, copy the general form of the equation, and then you transpose negative 12. And then we have to complete the square. So first, we have to copy x squared together with negative 4x. Then you leave a space. Then copy y squared followed by negative 6y. Then you leave a space for the third term equals 12. And then the third term is 4. How will you get 4? All you have to do is to take half of 4, that is 2, and square 2, that is equivalent to 4. And here the third term is 9. Where did you get 9? That is coming from 6 divided by 2, or the half of 6 is 3. And take the square of 3, which is 9. That is why the third term is 9. Since you added 4 and 9 here, you also add 4 and 9 to the other side to balance the equation. And then, this is the first perfect square trinomial, x squared minus 4x plus 4. And the second perfect square trinomial is y squared minus 6y plus 9. Then you combine 12, 4, and 9. That is equivalent to 25. Then you have to factor each perfect square trinomial. You can factor into x minus 2 times the binomial x minus 2. And here we have the quantity y minus 3 times the quantity y minus 3 equals 25. Express into square of binomial. So this is equivalent to the square of x minus 2. And this 2 is equivalent to the square of y minus 3. Copy 25. So the standard form of the equation of the circle is the square of x minus 2 plus the square of y minus 3 is equal to 25. Where the center is at 2, 3 and the radius is equivalent to 5 units. So from this general form, we're able to go back to the standard form. So this is the illustration. Again, we have the center 2, 3, radius 5, and the name of the equation with the point on the circle. Questions? If there is none, let's proceed. Let us have example number 2. Find the general equation of the circle whose center is with coordinates 2, 6 and whose radius is 3. Then you graph the circle. So we have the given h is equal to 2, k is equal to 6, and r is equal to 3. For the solutions, you copy the standard form of the equation. So this is the standard form where center is hk. And then substitute. H is 2, k is 6, and r is 3. Then all we have to do is to expand the square of binomial. So it's either you can use the FOIL method or the distributive method or the special product. So what we have is x squared minus 4x plus 4. And for the square of y minus 6 is equal to y squared minus 12y plus 36 is equal to 9. Then we have to remove the grouping symbol. Just copy and then simplify. So we have x squared followed by y squared, then negative 4x minus 12y plus 4 plus 36, and you transpose 9. So we have negative 9. Then combine the numbers and set the equation equal to 0. So what we have now is x squared plus y squared minus 4x minus 12y plus 31 equals to 0. So this is now the general form of the equation of the circle. And this is the graph. Center with coordinates 2, 6. The radius is 3. And this point with coordinates 5, 6. Do not forget the name of the circle. You have to write the equation. Example number 3. Change the equation x squared plus y squared plus 8x minus 6y equals 0 to standard form. And determine the center and the radius of the circle. And then you have to sketch the graph of the circle. So this is the given. For the solutions, you copy first the general form of the equation. And then you arrange and leave a space for the third term. Give a space for the third term and for the 2 additional constants. Then take the half of 8. And what is the half of 8? That is 4. Square it. And that is 16. Take the half of 6 and that is 3. Square it and that is 9. So what we have, x squared plus 8x plus 16 plus y squared minus 6y plus 9 equals to 0 plus 16 plus 9. So that is only 16 plus 9. Express the perfect square trinomial into the square of binomial, which is the square of x plus 4 plus the square of y minus 3. And 16 plus 9 is equal to 25. So the standard equation of the circle is the square of x plus 4 plus the square of y minus 3 is equal to 25. And the center of the circle is at negative 4, 3, and its radius is 5 units. This is the graph of the circle. Center negative 4, 3. The radius is 5. And do not forget the equation. Next, example number 4. Determine the general equation of the circle whose center is 3, negative 1, and whose graph contains the point 7, negative 1, and sketch the graph of the circle. Given h is equal to 3, k is equal to negative 1, and the point with coordinates 7, negative 1. For the solutions, first, we have to use the distance formula to solve for the length of the radius since the equation is not given. So, recalling the distance formula, r is equal to the square root of the square of x minus h plus the square of y minus k. So, x is equal to 7, h is 3, y is negative 1, k is negative 1. Then 7 minus 3 is 4. Negative 1 plus 1 is 0. 4 squared is 16. 0 squared is 0. And the square root of 16 is 4. So, the value of the radius is 4 units. Next, we have to find the general equation. Using the standard form, the square of x minus h plus the square of y minus k is equal to r squared. We have to replace 3 to h, negative 1 to k, and 4 to r. Then we have to expand. We have x squared minus 6x plus 9. And the square of y plus 1 is y squared plus 2y plus 1 is equal to 16. X squared plus y squared minus 6x plus 2y plus 9 plus 1 minus 16. You just simply transpose 16 and equate to 0. What we have is x squared plus y squared minus 6x plus 2y minus 6. Because 9 plus 1 minus 16 is equal to negative 6. Equate to 0. So the general equation of the circle is x squared plus y squared minus 6x plus 2y minus 6 is equal to 0. And the graph of the circle is this one. Center 3, negative 1. This is the point on the circle, 7, negative 1. And label the circle with the name. The name can be the general form or the standard form.